I'm pretty sure in our secondary school days, we have not something familiar to this, right? If you go to a good secondary school standard one, set theory, you know, Venn Diagrams, which was brought up to us by John Watts. John Venn is the one that gave us this Venn diagram. And the purpose of having a Venn diagram is for you to illustrate elements, items, objects in what? In diagrammatic form, which consists of those words, a circle and what? A rectangle. In those circles, or we can call it squares, that is where you have elements. Elements or objects. And what is being encrypted here? Tutorial manual. And here now, MTS was introductory. Like I said earlier, this one that will give you introduction to the whole course. When we reach on second semester under level, you do another MTS. But that one is MTS 1 or 2. Now, let's start with something. And I don't know whether your secondary school or your lecturer do kind of dictates to you sometimes, but I know most teachers will write on the board, have you? But now that you're in the university, you can't expect lecturers to write. Because they are called lecturers, not what? Not teachers. Teachers will write, explain everything. But lecturers, they just give you them. You have to sort it out yourself. Now, let's start with something here. Are we ready? You don't want me to dictate, have you? I should dictate? Okay. Sorry? I was in this project. Now, are we ready? If you are ready, say I'm ready. I'm ready. I am ready. If you did not shout for them, we will not start to. Are you ready? Yeah. I'm ready. Yeah, we are ready. Now, set theory. Set theory. Sets are collections of objects. Sets are collections of objects. Then you can open your bracket. Sets are collections of objects. Then open your bracket. Called elements or members. Called elements or members. Then you can close the brackets. Let me take it again for those just joining. Sets are collections of objects. Called elements or members. Then you close the brackets. That are classed together.
Bluetooth mode.
Sets are elements, are collections of objects called elements or members that are classed together. E.g., a set of triangles, spheres, and so on. Are you ready? We are going on. Now, sets are collections of objects called elements or members that are classed together, e.g., a set of triangles, figures, and so on. But I don't like the example used in this text. When we say collections of objects, like now, all of us in this lecture room, we are all students, right? We are classed together under this room, right? That means we are all in sets. Do we agree to that? We are sets. So we can say, let set A be equal set of all students, or number of all students by group. And I'll give you kind of real-life examples. You are going to get it easier, right? Now, all sets are part of a single large. Let me read this for you. I have my own personal notes. Okay. We said all sets are part of a single large set called the FUTA set. The FUTA set is a set in which all other sets are being obtained from. Do you get it? For example, now, your parents in the FUTA set. You are a subset of your parents. Your parents owns you, right? Your father and your mother, and you are the son or daughter. You are the subset. You are the offspring of what? Of your parents. Now, we are moving to set notations. Set notations. When we say set notations, these are ways we can write sets, ways we can illustrate a set, ways we can express sets, some elements or objects. I'll just get that, please. And now, we have, let's say, mainly two. The first one is the tabular form. And the second one here is builder's form. Just the normal builder's, then apostrophe S form, which is also known as the property form. property form. Now, under the tabular form, I'm taking that one first. Tabular form. How many types of notation do we have for sets? 2. The first one, tabular form, and the second one is what? Builder's form. Now, for this tabular form, what I will do is that this board is to be for explanation. While my own lecture, what I'm saying, you can join the two together and you have a very comprehensive note. Now, this tabular form is when you have the kind of sets. So as we have our head to be like this. Whenever you say any kind of set like this, here now you have set A to be what? Lowercase a, lowercase b, and what? C and what? And D. It's straightforward. And a way you can make a kind of tabular set, a tabular form, is that you have all of these brackets. Who knows the name of this type of brackets? What do you say? Curly brackets. Correct. I can see there are many things in this class. So this is a curly brackets. Mashallah, that is very correct. Are we getting it? The rent if you are in this kind of, maybe I don't know, some people, if they are in this computer department, we are coding some programs, so you come about it. That's it. But many people call it what? Brackets. Most especially in mathematics, they call it brackets. But mind you, this and this, they are not the same thing. The correct notation for tabular form is this first one. Are you getting it? This second one is what? It's out of it. Is that aspect clear? Now, let's go into the second form, which is what? The builder's what? Builder's form of what? Property form. I'm pretty sure while people were preparing for our head, LabTech, or JAM, you study a lot of series, and maybe on that set, you have some particular questions like this. You can just do something like this. So when you see something like this is not the expression. Please, everybody, let's look at the board. Please, like I said, this board is for explanation. And what I lecture out, what I say, you can join it together and you have a comprehensive notes. Yeah, now, who can kind of read this thing for me? I don't know it. Who can read this for me? What's this one? Curly brackets. What is this? Come for yourself, come for yourself. I see this is your only brilliant thing. I was holding there, but I don't know what I'm doing now. Okay. X, What do you say? From this side, what is that? Elements, okay? From this side. All in numbers. Like that, just that. I don't know what that is. I don't know. But that thing that looks like he, that symbol, what is it called? Elements. You are copying them on. Is it elements or he? Is he I'm seeing on the bottom? Is an element. You guys are really brilliant. Okay, now let's continue. Let's translate this code. X, so that X is an element of what? Numbers, less than 5, correct. And in some cases, this big hen, let's say mostly other sets, it is known as natural words, numbers. And in some cases, you might not see this hen, it might be this R you see. What does R mean? Real numbers. And if you see I, what does this mean? Integers. You guys are really brilliant. And integers comprises of all counting numbers, both positive and what? And negative. I'm enjoying this class. I'm feeling your vibes. Please don't stop that vibe. What do I say? Don't stop it. Let's continue like that. Okay. Now we are moving to type of sets. Type of sets. Because there's no way you have a kind of a thing that you don't have a type. But we are taking it step by step. Abi, the first thing we do is that we first explain what we know about set theory. Then we move to what? Sets, notations. And now, where are we moving to? Types of sets. Okay, the first type of set I have there is empty or null sets. Empty or null sets. Null sets. I'm pretty sure we all get the spelling of that word set, right? Can someone spell it for me? L M. Okay, it is N-U-L-L. Correct. So, like I said, the word is just meant for explanation. Now, empty or not set. From the name, empty or not set, what can you say about it? You see something is empty, something is null. Yeah, just stand up, let me hear it. Without anything in it, any element. So from this side, it does not have any element. Okay, but I have a question. Are you ready to answer it? When we say it has no element, we all know that under the basics of mathematics, 0 is nothing, right? And we said this not set is a type of set that does not have any elements in it, right? Now let's assume I have something like this. We have A, then 0. Is this, how can I do this? It's set, it's not set. Which of the two? It is a set from this side. I can see this will be not correct. Yeah, a separate answer. Don't mind them. From this side now, which type of set is this? It is also a set, Abby. Correct, it's a set. Now, for you to express what way you can donate your empty or not set is when you have something like this. Or you have this symbol. Do you see it? To express or donate your null or empty set is when you just have what I call this? Your curly bracket, nothing inside it. How to get that? Or you have a 0, then it's true. That is what not set. So this one now, can we call this one a not set? No? Are you sure? Why? Why is it not a not set? It has a number in it, even though the number is nothing in normal mathematics, secondary school mathematics, primary school mathematics, but when you reach university, not only FUTA, when you see that 0 in that small bracket, it is not a null set, it is a unity set. And when you say unity set, a type of set that just has only how many elements? 1. If you take other mathematics, there are some parameters under set and some other topic. When you say something is unity, that is 1. If you've done matrix also, there are some type of matrix that when you just have 1. Some are identity matrix, some are unity matrix. And this type of unity sets now, some people of us, it's also termed as well singleton. What do I call it? Singleton. That is just one single, then singleton. Okay, the next type of set now here. Finite sets, finite sets. What's the pronunciation? Is it finite or finite? Okay, it's finite. I'm sorry. Finite sets. Finite sets. Okay, someone said unit again. Okay, don't worry, I'm mixing the two, so we should not have to more in this lecture. Finite sets, finite sets. It is a type of set. It is a type of set, or I can say this is a type of set in which all its elements are what? Someone should complete that word for me. When you say finite sets or finite sets. So, it is a type of set in which its elements are what? Are what? Countable. God, people are brilliant to Kayaya. You are brilliant. Okay, countable, okay, that has a countable number of what? Elements. You can count it. Now, can anybody give me a real-life example of a finite set? Real-life example, just think. Then give me a kind of, okay, someone is there. Let me take this guy first. Is it? Okay, sorry, sir. I'm sorry, sir. You are the one?
All even number between 1 and 30.
All even number between what? 1 and 30. It's a type of finite set. But I need a real life, like something around you. That means that, oh, this thing. Number of? In your house. Okay. Okay. I have one hand here again. Okay, please let me take this out first. I'm sorry.
The number of fans in this class.
This guy is so brilliant too. She said the number of farms in this section. Okay.
All number of federal universities in Nigeria.
God of mercy, people are brilliant. All number of federal universities in Nigeria. Is it a finite set or an infinite set? It's finite now. You can count out the number of universities in Nigeria. That is a finite set. Now, I promise it's here. Okay?
A great object.
This guy love head. A great head. I'm sorry, it's kind of insulting. A great of head. Now, let us waste much time on that. Now, the next type of set we have is infinite set. Infinite set. The first one I said is what? Empty or null set. You all understand that, right? The second one is what? Finite set. We've just done that. And keep sure that stick to our memory, right? And the one I said last is what? Infinite set. Finite, infinite. What and what? Opposite. So who can say what is an infinite set? I don't know it. Let me hear your voice. Raise your hand. Yeah.
Type of set in which all its elements cannot, like it is uncountable.
This guy is brilliant, If you get it right, round of applause for our please. He said it is a type of set in which all its elements are not counted. That is kind of infinity. Okay, now that is the mathematical words meaning. Okay, you can just say that has an uncountable element. Do you know what? It's not compulsory kind of use grammar while you're writing your notes. Just use and write your notes in a manner that you know that you reach example or more, you get it right. Because now you're another level, you are going to take CBE for all your examinations. CBE, except if you have more departmental courses you are covering that will be written. And for CBE, you don't just go for your intellectual, for your smartness. Now, you are just writing grammar in your notes, and when you reach CBE center, because I didn't know your census this time around, but last time I think you were like 5,000 something on the level.
6,800.
60,000 a year. And you enter that CBE. You enter that CBE, some will faint, many things will happen. But I can see you are not the lucky ones. For you to attend this tutorial, nothing will happen. To say amen. Okay, an example of an infinite set now. Anyone? Okay, yeah. Number of stars in the sky. Can we count it? Are you sure? Me, I can count it too. I can count it. Okay, another example. Yeah. Number of stones on the floor. Is this an infinite or finite set? Infinite set. I know people are genius, okay? Yeah. Number of set of even numbers. Yeah. Number of what? All even numbers. It does not have an evidence number. It's uncountable. Do you all accept that? Are you sure? Because if you start now, 2, 4, 6, you reach 1 million, 1 million and 2, 1 million and 4. You continue till eternity. I'm giving you that some kind of more numbers that are yet to be discovered. Do you accept this with me? Okay, from this side, just 2 examples, they will call it, okay, you?
A set of numbers.
A set of numbers. Which type of number? Must specify that number. All numbers. And you? Brain of light. This is no friend. This is no friend. I'm not going. Okay, last year. Member of. Number of rice in the sun. And calm down. Do you agree with me? Do you agree with me? Should I give us an assignment to count this? Okay, the next type of set we have here, we have universal sets. Universal sets. If you have a question, please raise your hand and then I'll attend to you. Do you hear that purpose of this tutorial? Universal sets. Universal sets. And for you to donate to the universal sets, it is mostly written like this. Or you have it like this. But this is you. I can say it's not like kind of internationally accepted. That's the universal set. I'm not going to tell you what the universal set is. Okay? Yes, okay. I need another volunteer. Universal set. Okay?
Now, the universal set is the type of set in which all other sets that are subsets in which they can be argued.
In which
They are contained.
they are contained. Ah, this guy is a mathematician and secondary school. Clap for both of them, please. Love that. You guys are really reading, and that's the best part. So you can say a universal set is a set that contains another set or some other what sets, which are called subsets. Like, I don't know, before most of you join, the first example I said is that everyone here is a subset of what? Of our parents. Do you get it? Subsets. We're having subsets now. Subsets. Should we dive in? Okay. A set that contains elements. A set that contains elements that are part of a bigger set. Should I take it again? Okay. A set that contains elements that are part of a bigger set. Do you understand that kind of phrase? That is a set that contains elements that are part of what? A bigger set. Now, let me explain that aspect now. Let's assume we have our set A to be A, B, C, D, E, F, and G. Then set B now. We have it as B, C, and D. Now, please, let's focus on the board, please. Just to explain that terminology. This is set A, right? And this is what? Set B. Set A and set B, they are not empty sets, right? They have elements. And now, between set A and set B, which one is the bigger set? Are you sure? But B is kind of fatter than A. Set A is bigger set than B. Oh my God, those trying to confuse you. Set A is the bigger set. And B is the what? Smaller set. Now, someone says some sets, I'm coming there. Now, can we all read out the elements in set A? A, B, C, D, C, D. And now, what's the definition of subset I gave you? Can we read it out? That contains elements that are what? Part of a bigger set. Now, this is set B, Abi. This is the bigger set. We have B is here. We have C is here. And we have D is here. This contains elements that are part of what? Of the bigger set. B, C, and what? And D. Please, can anybody tell me the time there? Time.
2:57.
2:57.
2:57.
3:57.
2:57.
2:57. Okay. Now, okay. I expect you to ask me a question under this subset. Who is that person that will ask me the question? Under subset. Expecting a question. Yeah, go back to your memory lane and scatter your skull, go to your lexicon. Then fetch us a question under this subset. Your subset. I expect you to ask me just a question, just one question under the subset. A question. Okay.
Will you say B is a subset of A or A is a subset of B?
Okay, that's a good question, but that's not the question I'm expecting. She said, what will we call the elements of what? Elements of B. Now, if you want to say this type of thing, B is a subset of what? A. Because all the elements of B, we took them from what? From A. Do you understand that concept? Okay, your question? What if
all the elements in B are not in A? We still call B a subset of A.
all the elements in B are not in what? In A, then it's not a subset. Okay? Correct. He said, what if all the elements we have in A are also in what? Are also in B. It is a subset. But in that case, it's another type of what? Subset. We are going there. Just remind me the question. Is it not equal sets? We are going there. It's step by step. I don't want to just branch, you understand? I've already given out a very perfect layout outline. Hey! Don't give this. You're looking at this guy too much. You're looking at him too much. And I know this guy is looking at him too much. It's the one that's looking at him. I'm just joking. Starting this is sorry. Now, let's come back to class. Other these subsets now. Those two questions that you asked, someone has that. What if the elements in B are also the elements in what? In A. That is, they all have the same elements. That will now lead us to type of subsets. Type of subsets. Yes, right, it's part of the note, types of subsets. Though, we can now see that type of subset now. It's a subset of what? Of subsets. Do you have that in this? Aha, now you are getting it, Ali. Now, we have the first one, a proper subset. Proper subset. Proper subset.
Thank you.
Proper subset. Okay, should we move on? No? Okay, I'll take it again. Types of subsets, then we have what? Proper subset. She's smiling because I said I'll take it again. Okay, A, capital letter A. A is a proper subset of B. Oh wait, let's take it to respect to this example we have here. You hear? So you now think that B is a proper subset of what? Of A. Okay, let's have it. B is a proper subset of A. B is a proper subset of A. Then you open your brackets. Open the brackets. Written as written as this. After you open your brackets, then you insert this into brackets. This was the question I was expecting you to ask that. Oh, Mr. Man, he said subset. How can we generate subsets? What do you say? This guy is kind of rebellious, like, I'll treat your house and I'll screw it up. So, we said what? B is a proper what? Subset of what? Hey. So, this sign that you see here, this one, is used to relate to what? Subsets. Proper subsets. Okay, your question? That symbol, okay? You. No, there are different concepts. Don't worry, by the end of the class, I will give you a kind of table, symbol, their name, and their functions, right? I think you like these diagrams. Okay. Now, let's continue the notes. If, then you open your brackets.
What time is your prayer? I should remind you. It's around 4 o'clock. And it's 4 o'clock.
Okay, if, then you open this bracket and write this. If this B subset, they have a kind of line under A, then brackets close. And
that block means this guy, I can ask for you now.
okay, if A, you write this, and B not equal to A. Don't worry, I will listen to you here. Just chill down. That is, B is contained in A. B is contained in A. But not equal. That is, B is contained in A, but not equal. Now, let's explain this aspect now. Because we need a duster. Should I sacrifice my handkerchief? I need to say this again. Anybody that will give me a duster is like, okay, but this guy has been cleaning now.
It's a paper. Okay. It's a lost.
I don't want to say that paper because the person can come and arrest me every time. I think I'll use that shade the paper. Who do you like not here? Don't worry, I will not let you see it. Forgive me. Do you forgive me? I knew you say no. When someone has the feeling with that hardship, then this cannot sacrifice it.
Yeah.
Okay, now, proper subsets now. Please, attention. Proper subsets. Let's assume we have our A to be, we have set A to be 1, 2, 3, 4, and 5. And we have another set B to be 3, 4, and 5. Now, in reference to subsets now, you can say B is what? It's a subset of what? Subset of A. Because elements in B are contained in what? In A. And this type of set is called what? Proper subsets. Do you all understand this? Aha. Now, in the case of improper subsets, I will explain this now, then I will give you the clue. This after the explanation. Should we do like that? In the case of improper subsets, it's when you have your B to be 3, 4, 5, 1, and 2. Please, let's look up now. This is set A, right? This is what? Set B. These are the elements in set A, these are the elements in what? In set B. Are the elements the same? Are you sure? Open your eyes and look at this very well. Is it the same? They are the same. Though, it doesn't. Now, can I say B is a subset of what? A. Then this equality sign you have here, this sign here, this one, this stroke, it means that the elements in B are also the same elements in what? In A. Are we getting it? But it does not mean that what? B equals what? A. That's the statement here. That means though they have the same element, but B and B are not the same thing. Do you understand that thing, please? We have same elements. I'm weighing the chest, right? We are weighing the chest. Same elements. Clear, right? But are we the same thing? No. I have the pen, you have the pen. Same elements. But are we the same thing? No. Please, do you understand it? How mouse like that? Likewise, you have this. I mean, we have the same elements, same common elements. But are we the same thing? No. I'm human being, you are human being. I'm a day, you are female. I'm not the same thing. Clear, darling? Now, improper subsets. I think I've explained proper subsets for you now. Now let's have the notes. Improper subsets. Should we dive in? You have a question, okay?
Please don't have to say that A is a subset of B. Mention that B is a subset of B.
He said when B is a subset, okay, when A is a subset of B, when B is a subset of A, does that mean A is a subset of A? Yes and no. Let me clarify that aspect now. Please, that boy should look up and that boy should look up. This is B, right? This is A, Abi? Aha. 3, 4, 5. 1, 2, 3, 4, 5. B is a subset of A. You all agree with that? Aha. Now, can we now say A is a subset of B? No. You all agree? Another evidence. What's the definition I give you of subsets? Check your notes and read it out. That it contains elements that are parts of what? The bigger set. So that means a smaller, a bigger set cannot, it will contain no, but it's not falls under the smaller set. That boy, you've gotten it, Abi. Where's that man? Is this boy your man? You are the one, sir. Man, the sir. Okay. A is an, let's come back to the notes. A is an improper subset of B. A is an improper subset of B, comma, if A subset B and also if A is a subset of B, and my friend that should the next person to follow. If A is a subset of B and also A equal to what? B. If A is a subset of B, comma, and also A is what? Equal to B. That's what I explained in this place. This is our A here, this is our B here. Though B is a subset of what? A, Abi, but they have the same elements, Abi. This stroke you have that you see here under this subset sign, it means that it is an improper subset. Are you getting it? But the real symbol to do this subset is this one you have here. The ordinary one without the stroke under your question. It's not for that one. You know the question, it's not too hard.
Can I use this phone instead of that one first? So I should come and write it on the board.
Very nice. Please, if you have any question, ask me. Yeah, that's why I doesn't give you tutorial. Ask. You can say that when they are expressing sex for that notation, that can we express our sex like? Okay. Yeah, come from my write this. I know I'm not good though. You don't say that. Say it. Yeah, it's on this one. You have a long way to go. Hurry up now. Okay. Thank you. This is a still be a subset of what? A. Well, that's a very good question. What you mean is that though they have 3 words, 4, 5 here, Abi? No. The 9 is included in this place, Abi. So now that will this still be a what? A subset of A? No, it will not be. Do you get it? It's not because 9, that's 9. It is not in the bigger set. Please, you all understand it? Aha. Now let's continue the notes. Please, let's first question. Keep your question. I will surely answer your own question. A is an improper subset of B, comma, if A subset B and also what equals to B. We've done an example under that. Now, supersets. Super what? supersets. Supersets. Should we move on? I want to tell you again. Okay. Supersets. B, capital letter B, is a superset of capital letter A. Your uppercase B is a superset of the uppercase A. Open your brackets. Written as this. B is a superset of A. Then have that on the board. If every element, of A is in what? Is in B. What is it? Come again, alright? Superset. B is a superset of A. And you open your brackets. Written as boom. Close the brackets. If every element of A is in B. If you notice, let me say, this symbol and this symbol, they look alike, right? Aha. But this one is for what? Subset. And this one is for superset. What changed? You know what? Their direction. That's changed. The same case, you have proper subsets and what? Improper subsets. You also have it in the case of what? Proper super what? Set and what? Improper super set. To express now in this type of superset now, is this proper or improper? Okay, yeah, wait. Can you all see this? Which type of subset is this? Proper subset, correct. So this one? Improper. This one called? Proper, super, bravo. And you have this one? Improper superset. The same case with those subsets, the way I explained those terminologies was also what applied to the case of supersets. But because of time, because I want us to reach some really inputs, I can't say complex because there's nothing complex in MTS. I don't know. Because I know everybody here about genius. Now, okay, notes. Let me give you a notes. Notes. What do you say? You are not seeing the board. I should explain that please again. I should just say this. This line. Okay, what is this? Proper subset. And what is this? Improper subset. What do we have here? Proper superset. And what do we have here? Improper superset. You don't get it again? Hey, don't worry, come and meet me later. I'll go contact you. Now, note. If A, your uppercase A, then you put the symbol of, I want to test some knowledge, I'm pretty sure we're all genius. You put the symbol of improper supersets.
It's okay.
Improper what? Supersets. I'm pretty sure we all know it now. B. Then put the symbol of improper supersets. Put the symbol of improper subset B. Then CHEN. Then B. Yeah, then CHEN. Then B. The uppercase B. I show you again. Note, if uppercase A, improper superset B. That's it, if uppercase A is an improper superset of what? B. Then, use a comma. B, improper superset of what? A. Then B is an improper superset of A. Like this 5 superset. I should have again. Okay. If A improper superset B, then comma B improper superset A. Someone is raising out for question. Or do like a putting question. Please just let me know the question. Because if A, like that was the question this man had.
The first and small small. You don't want to have
If A is an improper subset
because you know too
of
much.
B,
You
so
don't
let me give you some quick tips. Okay. Before that, equal set. That's the next one now. Equal set. Are we ready?
Yes.
Okay. If A, you have set A to be 1, 2, 3, 4, and set B to be 4, 3, 2, and 1. Set A 1, 2, 3, and 4 as the elements, and set B you have what? 4, 3, 2, and 1 as the elements. So what can we say about set A and set B? They are equal to each other. Why do you see that they are equal? They have the same elements. So let me now conclude with your note. Then A equals B. Then A equals B. Okay. Now, move to the next line. Properties. I want to give some properties of this equal sets. Properties. Then properties and keep your column. Yeah, properties. Equal set. Yeah. Okay. Properties. Under equal sets.
Should I address them badly? Read for. They have eyes now.
It's like Gabriel, I told you to do.
separate this.
Okay. Back to class. Okay, now let me begin this point. The properties I give you now. Equality is reflexive. Okay, don't worry. Let me start from there. Equality is reflexive. Open brackets. A equals A. Brackets is symmetric. Now, okay, and overall this space are different. It's not true. Okay, now. Open brackets. A equals B. A equals B, which implies that B equals A. That is under equal sets. That if set A is equal to set B, then automatically what? Set B is equal to what? Set A. Then brackets close. That is their transitive. Now, the second one now. When does set A equals set B, comma, and set B equals what? Set C. Then it implies that set A is equal to what? Set C. That is when you have three sets. And they are all what? Equal. Okay, if A equals B, that is set A equals B, comma, then B equals C, that is set B is equals to set C. It implies that set A equals set C. That is when you have three sets. Now, this is what I want to solve now. I want to do this place now. This place now what? We do that one see. This place now what? If A equals B, if A equals B, then if A equals B, then number of elements in A, that's NA. It means number of elements in A equals number of elements in B. Same cardinality. Have you ever watched cardinality before? When we say, oh, what's the cardinality of this set? It means what are the numbers of elements in this set? Do we get it? Now, let's take this one now. This is set A. What is the cardinality of set A here? Huh? Okay, some people are listening, some people don't tell me the exact figure. But you have talked about cardinality of the set. It is the number of elements, not the element itself. How do you get it, brother? You have to count those number of elements. And how many elements do you have there? 7. So that is what we mean by what? Cardinality of a set. Okay, let me continue. But the compass is not always true. That is the opposite is not always true. Or something related to that, which is the equivalent to what? Set. On that type of set, you have equal sets. The same way you also have what? Equivalent sets. You know, on a normal basis, you'll be like, oh, equal sets, equivalent. They are the same words, they are the same thing. But the difference is that they are different equal sets. Don't take this as one. Equal sets is only this with the cardinality, that's the number of elements. Are you getting it? But in the case of equivalent sets, this with the elements what? Itself, the elements go. Then yeah, I said notes. For equal sets, order of listings, arrangement does not what? Matter. Only what? Membership. That is those elements. Do you get it? Don't mind this speaker, it's screw us up. Equivalent sets.
One.
Should we move on? Why? Come on, let's go. Equivalent sets. Should we move on? Yes. Set A and B. Set A and B. Set A and B are equivalent. Set A and B are equivalent if they have the same number of what? Elements. Should I come again? Set A and B are equivalent if they have the same number of elements. And what do I call that number of elements? Cardinality. Jam your hands together for yourself. But if you are a Muslim, you can do mashallah or you have to have power for yourself. I'm also a Muslim, so don't look somehow. Now, let's continue. It can be denoted as the modulo of A will be equal to what? Modulo of B. That's when you see something like this, stroke, and you see something in between. If you have to read that out in mathematics, take it as modulo. Or you also have another expression. Or A, something like this. I don't know what is the working sign. So other equivalent sign, not to denote that set, is equivalent to this set. Write it as this. Or A, E, and B. Who knows the name of this sign? It's this one that you see here. This one. If you are what's the name? This one is equal to, that is when a kind of operation is equal to another operation. Operation on the right hand side is equal to what? Operation on the left hand side. But this one, equivalent. Are you getting it? It's another kind of aspect of the soul. Equivalent and equal to, they are not the same. Do you get it? Yeah. Please don't take it together. Now, example. Let's have some example now. Example. If set A, example, don't worry. Okay, don't worry. If A equals, you have A, elements in A, 1, 2, 3, then close the brackets. Elements in A, 1, 2, 3, then close that your curly brackets. Are we free to go? A, 1, 2, 3, then close it up, and your set B, uppercase B, equals lower case ABC, that is your ABC, small letter A, small letter B, and small letter C. Then close it up. I take the name. Okay, if A equals 1, 2, 3, close it up, and B equals small a, small b, small c, then you close it up. Then, what can you relate from this? Are they, which type of set is that? Are they equivalent sets? Yes. Yeah. Yes. Are you sure? Yes. I'm not sure. In set A, you know we only have 1, 2, 3, have you? As elements. But in B, you have what? A, B, and C. So how are they equivalent? Okay. Same number of what? Their cardinality. Number of what? Elements. That is it. So that means we can conclude that what? Set A is equivalent to what? B. Have you? Or A, then what? Then B. That is the difference. In equivalent sets, let me explain this again. In equivalent sets, this is what? The cardinality. Clear that? Aha. But for equal sets, if this is those elements, are you forgotten that area? Please don't mix it up. Light it again. Light it again. Oh, I should make it scatter. I should leave it like that. I should leave it like that. Maybe it's not called something sometimes. Okay. Yeah, I think what's the time? What's the time? Okay. Now. And okay, let me give you this example. Example like classroom. Give me the answer yourself. Example 2. If set P, you have your set P to be equals A, B, C, and D. That's set P. And Q to be equals A. Sorry, don't use this bracket. Make sure you use the normal brackets. Q to be A, B, C, and D. 2A, not 2A like exercise GT. We have 2A. A, sorry, set B, A, and your set Q, A, which type of set is that? Can we say, oh, this is an equal set? Oh, this is an equivalent set. What do you say? Okay, wait, from this side, those two sets now, they are equal set and equivalent set. Wait, don't tell them the answer, don't tell them the answer. We are just going to some sets equal, they are not equal. What's your good? They are equivalent. Equal sets. Okay. Why this side now? Why you say they are not equal? They are equal. Yeah. Okay, why do you say they are equal here? You cannot repeat
A element twice.
repetition. Instead, it's not allowed. If you have like that is that you have 2 A's. Are you together? That you have 2 A's. You only take what? 1. Even though you have 10 A's, with 2 words, take 1. So when you take 1 A here, this type of set is that now. Equal and also what? Equivalent. Why is it equal? Same element. Why is it equivalent? Same cardinality. Do you get it? Yeah. And jam your hands together. I see. You guys are moving or you're moving. Okay. Now, on equal sets, the same way we have equal sets, equality sets, we also have our Judas, that is what? On equal sets. Now, let's move on equal sets. Okay, we're almost done. On equal sets, what's time?
340.
340.
40.
340. Okay, on equal sets. Should we move on? You have a question? You let me listen to your question. Maybe okay. About
the Q, the first one.
this side.
The one you just gave us. Yes. So I'm sorry, I am saying to that. No repetition of numbers. That is not possible to give like 2A, B, B, A, C. That set must be either A, B, or C, D. Like I want to ask you, are you the one that formed this question or it's normal question?
It's a law.
Sir?
It's a law under set mathematics.
Yes.
When you have single elements in other sets, just take one element. That at least 2. There's one element that is not in the other set. Are you getting it? That is, there is one element that is not in the other set. When you have set A and set B, how can we say they are not equal? That means at least. They don't say at most. There is 0 between at least and what? At most. At most, that means many. At least, okay. How do you back to say it? Okay, so at most, one element, like it's not the sense, but what? Are you getting this? Just like this class, at least must have one fan. At one fan. But if you want to say at most, you have up to 30 fans. Now, which is written? For you to do this on equal set, you just on equal, this kind of on equal. That is the right hand side is not supposed to work. It's not supposed to be left hand side. Okay. So now, if you notice, there is no way you can treat set theory without moving the idea. But on the board, the beginning of instance, I'm not drawing a single circle. Neither have I drawn the rectangle, right? What do you say?
On equal sets, on the kind of example you gave to us, P and Q, in OBJ, if they say that set P is equals to the modulo of Q. Is it true or false?
Is it true or false? If set P, is it in modulo format or not?
No, so the right P.
In modulo format, okay.
Is it true or false?
If that is not unequal,
like if they are
okay.
is equal to the modulo format of Q.
Okay, ordinary P without.
Yeah.
No, it is false like that. Please, just ask me that for that one. And that is the way FUTA is to test your IQ, like seriously, FUTA. It's not a matter of being like, I'm kind of brilliant. You have to be smart. You study beyond the box. Are you getting it? Not only high intelligence quotient, but smartness, creativity, and creativity. We need it. You know, yeah, I said, what do you have there? This one now, I said this one is modulo format, Abi. You now said, let's now assume this modulo is not there. And I just gave it A, Abi now. Then the quality sign, and we have what? Modulo of B. The now has the question, that type of question, is it true or false? What's the answer? False. That is what you have on the right hand side is not equal to what you have on what? On the left hand side. Understanding. Now, I'm very sure all of us understand what we are learning about. Okay, now, I was saying that diagram I'm looking towards Venn diagram. Those things we learned this morning. Now, we express it in words. In the Venn diagram, the main one. It's better you understand the theoretical and also what? The practical. So that practical now is what? The Venn diagram. Please, can anybody just sacrifice just one use test just at here? Please, this paper is rubbish. It just doesn't give us. Anyone? Yeah. Pass.
Is that not money? Oh, thank you. I thought it was 1K. You can use it too, actually. You just use the money to clean the body.
So before I start the diagram now, I will brush us through complements of the set. Then after that, we move to what? The diagrams. Then after that, we finish it off with difference and symmetric difference of the sets. Are we together? Okay. Now when we say complements of the sets, I'm pretty sure in our secondary school, we want to say, oh, A complement. Write it like this, Abi? Yes. Or you write it like this? Yes. I know. And that one, you will not say it is A raised to power 1. What will you call it? A prime. People don't know what that prime means. People know that prime. But A prime is called it for 5 now. So, the definition, when you say something is complement, for a complement to exist, they must exist, let's say the universal set. Do you agree with me? A complement. Let me explain this in real life this thing now. I said we are all subsets of our parent, Abi. That means my parents, your parents, is universal set, Abi. And what? Subset, Abi. Which type of subset am I? Am I a proper subset of my parents or improper subset? Okay, wait. On this side. On this side. On this side. Proper subset, Abi. Improper subset. Okay. On this side. Proper subset. This is why. He said proper subset. Some elements that are contained in the universal set, but they are not equal to that bigger set. But for improper sets, we have elements contained from the bigger set, but equal to that to the bigger set. Now, some people say that they are improper subsets of their parents. Why? Let me give the answer. Oh, I respect my dad so much. So I'm improper subset. But that is a false. Why? Ask me why. Because if you don't just go for one element, you go for some other characteristics, features. Like now, are you rich up to your dad? But there are some subsets that are kind of really richer than their daddy. And some, are you intelligent? Emotional conscience, do you have up to your daddy? Yes. Financial stability, do you have up to your daddy? Yes. stage, let's take the answer. Go and face problem, go and marry, go and be a child. Go and meet house, go and marry house, send your children to FUTA. Then you are giving over success. Now, should we continue?
Specifically, FUTA.
When we are talking about compliments of the sense now, the mathematical expression, just this mathematical expression for compliments. That is, you take away elements that are not in the words divided as sets. That's just it. Don't worry, I will still give us principles or examples to solve. But remember, that's something we are doing. Adina? Okay, now. Very good, is that was all? Yeah. Okay, let me go check my time first. I mean the grammatical blunder now. Who knows that blunder I made now? I just made the grammatical blunder. Can anybody tell me the answer? I said, let's me firstly check the time first. It's a grammatical blunder.
Tautology.
It's a grammatical blunder. Okay, this is 3052. Once it's 4:05, please let me know. Do you hear? Muslims here, 4:05. What do you say? Time. And once it's 4:05, just alert me. Okay, now back to class.
How many minutes? Say, I'm not checking for the prayer. Say, from here to there, we end this 25 minutes. Go and come.
Okay, you are going to mosque.
That 81 place I used to pray, you know the place. 81.
Which one?
That's all down. I can't pray around this area. There's no anything.
There's no what?
There's no way we can pray around this area.
There's no water.
And plate.
Now, okay, this type of diagram now, this is the Venn diagram, Ali. But who can tell me what this one represents? This set A, I mean, these are universal set A, right? Now, what does this one represent? Compliment, Ali. From this side, you go. A compliment. Compliment and A compliment. I think the same thing. The question is that this diagram is board. What does it mean? What does it illustrate? From the left hand side there, someone said compliment, and here someone said A compliment. Compliments of A. A compliments. Now, we have another diagram. I'm coming to this. That's the total set here. This is set A.
Work hard and work
And you have set B. We have something like this. What does this one represent? I don't know it. A did not big compliments from this side. Now, from this side, what's the answer? What's the answer here? A did not big. No confidence this side. No confidence. What's the answer here? No confidence. What's the answer here? Am I saying you see? A, this is sample for A, this is for B. Element of A, B, element of B, A. And element is between also. They are all shaded. That is all of them what together. I mean, that is what A union what. And to write it is like this, Abina. Am I correct?
Yes.
Are you sure?
Yes.
So this one is the next union of the set. Union. And now we have the diagram like this. These are universal sets here. A and B. Let's look at the bottom. This one that it is only the middle they shaded here. I don't know why they shade the middle. I don't know. So, what does this one represent now? A intersection B. Are you sure?
What is this last part? No, we do one more part.
See, this side, don't mind them. Don't mind them at all. What does this one represent? You follow them again. Thank you, Charlie. This one.
This one. I don't know why they shade the middle. This middle part, what does that mean? A, you know, B. Why are you copying them? The correct answer is A intersection. Diagrams together. You are really thinking nice. I love that. A intersection. Okay? You have another diagram here, diagram here, diagram here. Okay. Now, I forgot something. I'm so sorry. Other type of sets. You also have what? Disjoints. Sets. And you did not remind me. Disjoints. The way I remember that they did not remember. That means we are what? Improper
Sets.
Yeah. Joints and disjoints. That joints. That is when you have. Let me just explain this too. When you say there's nothing like joint sets, but it exists. Are you getting this? So instead of you saying joint sets, then you say intersection. Are you getting this? Because our aim, what we want to derive in that joint set is elements that is in this set, and it's also what in this set. Elements that are common to two different sets, two or more different sets. I mean, so that is intersection. So instead of calling this a joint set, what will you call this? Intersection. Now, these joint sets. Let's write it down, please. Let's include so we don't forget. This joint sets. I'm sorry. This is my brain. I didn't know what was wrong with this. This joint sets. Okay. This joint sets, or we can say set A and B. Set A and B are these joints, or can be said to be these joints. Are you getting this? Set A and B are these joints, or we can be said to be these joints. If there exists, T-H-E-R-E, if there exists no elements common to either A or what? B. Should I come again? Yes. If there exists, okay, I start from the beginning here. Okay, I feel I should be able to take it because I'm reading this subject. Okay, set A and B. I feel it's the same thing. And set, okay, are these joints all set to be these joints? If there exists no elements common to either set A or what? B. This joint, that does not have any intersection, nothing between them. Do you get it? Now, the illustration for that one is this. What do you people call this one? You are the one that said that I'm not the one. Don't mind me, you are correct. Huh? Intersection. Now, this diagram, let's have some keyboard. B set A. B faster. This one, they did not shoot anything. I don't know why they did not shoot anything. What does this one represent? Are you sure it's this side? Yes. Don't mind me. That's what it's this side. What does this one represent this side? This joint. What do you say? I don't know how to do. This case, they are different because
they don't have common elements.
That's you guys are already you don't have any elements common to both, have you? There's no elements in A, no elements in A that are common. Because this one now, there are some elements that are common, so they put them together. That's why this is shaded. But for this one, nothing. That's why so this one is what? These joints. These joints. And okay?
Sorry from the bottom, now we here. Sorry from the bottom, now my OG's fucking dead.
Forward. Forward. Why, what's this 405? 405. I said 405, I'm done.
It's like after this, like after when you're done in 4 or 5, like, you still remain a FUTA program.
Just one, this difference of set class C. Difference of set, I put all this class, just this.
I mean, I can explain it. Should I just write everything?
Yeah, sure. Okay, now let's continue, please. Look up. Are you scared, huh? This one now, this one we do not have rectangle here. Are you looking up? No rectangle in this place. But we have a circle here. We also have another circle here. This circle that you have here, this one is for set A. And the one you have here is for what? Set B. And now, we have elements of A. Can we read them out? A, and you are. And in this place, what do you have here? Correct. So, from all the things we've learned in set, what can we say about this thing? This side.
This one is better than the way it's going. This one has control.
But can you upload to GitHub?
I should. I don't on data. If I on data, I'm lost.
The Muslims say, make sure you write the people okay, let's start 1 minute first.
1 minute.
Yeah.
1 beautiful minute.
I'm sure you come back. Come back. On my time, yes, 4. Okay, now, have something like this. Please, let's look up. Let's concentrate here. Have something like this, please.
You introduce the last topic before you go.
Yeah.
We'll come back for it. They should give you 10 minutes. Those are 15 minutes meeting. They should give you 5 minutes or 10 minutes to call them. So me, I'll talk and write the light, but then I'll talk. We're going to write the text, I'll talk. So I'll write the man will talk.
Okay, now let's go back to that. Some people say it's 4 or 5 already. But on my wristwatch, what I'm seeing here is 4 or 4. So if you know what I mean. Okay. Wait. Let's watch it fast. Okay, wait. Come on now. We always wait. Now, let's look at this diagram. Let's go, please. We should be doing that like this. The first one says, can I have it like this? A minus B. Or you have something like this. A, then stroke, facing the left hand side. Then you have B. It's not compulsory you use this type of brackets. You can use your normal parentheses. A minus B or A, your stroke facing where? The left hand side and you have B. That is the way you express your difference of sets. Now, the difference of sets A minus B or A stroke B is the sets. The difference of sets, open your brackets, A minus B bracket close, or open the other bracket, A stroke facing the left hand side, B brackets close. It is set of all elements in A, but not in what? But not in B. Should I take it again? The difference of sets A minus B or A stroke facing left hand side brackets close. It is set of all elements in A, but not in B. Mathematically, how do you express this mathematically? Mathematically, you write it like this: A minus B equals your curly brackets X, such that X elements of A and X elements that are not in B. So, this way you express this mathematically. A minus B equals your curly brackets open X such that elements A and not elements in B. Your next line, this is the tip concerning difference of sets. You subtract B. Please write it down. Just a tip, like the brief understanding of it. What the difference of sets, what it's all about. You subtract B from A. You subtract B from A, removing any element A here with what? With B. Come in again. You subtract B from A. You can put an hyphen. Removing any element A share with B. Any element A shares with B. Now, example. Any element A shares with B. Example. We have set A. 1, 2, 3, and 4. And set B. We have it to be 3, 4, and 5. And now we have a question that says, Roman figure 1, you find A minus B. And Roman figure 2, B minus A. Please, let's all look at the board now, because it's time for us to break up the problem. A, 1, 2, 3, 4 are the elements. In B, 3, 4, and 5 are the elements, right? And we asked to do what's Roman figure 1, A minus B, Roman figure 2, B minus A. Now, let's take it from the lightest stage. What are the elements in A? 1, 2, 3, 4. Minus what? What are the elements in B? 3, 4, 5. Can someone remind me the definition for difference of the sets? If you remove what? A shares with what? B. Now, what are the elements A shares with B? 3 and 4, Abi. So you circle them. 3 and what? 4. What is left? 1, 2. So that means A minus B. No, that's good. But like we should take this 5, Abi. We will not take this 5. A minus B, just like your normal subtraction. You get it? Here now we have 1, 2, 3, and 4 for set A. For set B, you have what? 3, 4, and 5, Abi. The common elements in B and what? A. You take them out. Then what is left in A? That will be your answer. Do we get it? And the bigger sets. This is the smaller set, Abi. You remove this one from me. The answer is what is left after you remove this one from me. Abi now? So the answer now is what? 1, 2. Abi? Now, for B minus A, now we are let's do it together now. What are the elements in B? 3, 4, 5. Good of you. Minus what? 1, 2, 3, and 4. Okay, same approach. What are the elements A shares with B? 3 and 4, Abi. Boom, boom. Boom, boom. What is left in B? 5. So what will be the answer to this one now? 5. Is this one clear? Are you sure? Someone said no, Abi. I will take it again. The thing is this, A minus B, Abi. You have to remove elements that this one shares with this. Then the left over, after you remove it, that will be your answer. We get it, Abi? The elements in A, we have what? 1, 2, 3, and 4, Abi? Elements in B are what? 3, 4, and 5. Abi now? Aha. So, they share 3 and 4, 3 and 4, Abi. So, we remove this 3 and 4. What is left? 1, 2. We are not considering this one again. You get it? Now, same case apply to this. B minus A. Elements in B are what? 3, 4, and 5. Minus A. 1, 2, 3, and what? 4. It shares 3 and 4 with this one, Abi. So, remove them. What do you have left in B? 5. Do we get this now? Okay. Now I think it's time for that answer that is still promised by some of our hosts, or parts of our co-hosts rather. Though we are still going to move to symmetric difference, but I have the question. Now I will dictate the question. I'm not repeating the question. It's part of the rules. To know the question that we have authorization to the reward laid down. Are we ready? Are you sure? Okay, this is what I've played. Are we ready? Okay. I should be holding you. Okay, now let's have it. Okay, the question is this. Given, I will repeat myself. I must not break that rule. Given set P equals PQRST, brackets close, and Q equals PQTZ, brackets close. Roman figure 1, find P minus Q. Roman figure 2, find Q minus P. Full stop. Bye. You have 2 minutes. Are we ready? Okay. Set A equals A, B, C, D, E, F, G, H. B equals 2, 3, 4, 5, 6. What is the cardinality of set A and B? I will count 1 to 5. 1. Okay? A, B, C, D, E, F, G, H. What's cardinality? Now, the second question is what? Cardinality of what? 2, 3, 4. Then what's cardinality? 2, 3, 4, 5, 6. Okay, your both got it correct. So, Mr. Elijah. So, this person will get the first question for you. Just stay here, stay here. Now, the second question is this. Are we ready for the second question? No. Now, listen up. In a class of 100 students, just listen up, it's not calculation. If you can listen up, in a class of 100 students, 15 are male, while the rest are female. 15 are male, while the rest are female. 15 are male, while the rest are female. List the subsets of the universal. List the subsets and the universal sets. Your time starts now. 1. Okay, you start first. Followed by this there. What's the question?
The subset. Universal set is 100.
I'm serious. Oh yeah.
100 male and female. That's universal.
That's the universal set,
15 male. That's one subset.
That's one subset.
The second subset. 85 female.
85 male. Now, you have come out. You don't know it again. Okay,
I raised my hand after her.
I'm the way that goes.
Subset of
No, the subset is 2. Male is 15 and the female is 85.
female is 85. Jam down speed up for them, please. So, wait. Many of us know this, but the thing is speed and accuracy. Do I get it wrong? That is the way CBE will treat you.
Oh, more.
Right, so in most sometimes can have 60 questions just for 20 minutes, calculations. And you can testify to this.
Yes.
So all this one now, that will start doing themselves. Oh no.
So for that CBT, we'll add a new mode very soon before your test. The exact type, with the exact time and exact questions with you understand with FUTA on. We'll add a new mode very soon. But for now, enjoy the demo.
Now, you are diving into symmetric difference, so you can go and meet Mr. Elijah. So, symmetric difference.
The account number.
Yeah.
What's the point? Symmetric difference. How ready? Hey, the answer is first I think so the answer. I think everything is justified now. Now, symmetrical difference. Are we ready now? How about now? Symmetrical difference. The symmetrical difference of sets A and B. The symmetrical difference of sets A and B. You get it right? The symmetrical difference of sets A and B. Written Symmetrical difference. Okay? Another answer, please. Oh yeah, Elijah. Delta. Okay, one last answer. Expansion. Okay, like the expansion of the operation, Abi. Okay. The first two, they get it right. Okay. The first two, they got it right. What's your own answer? What do you call it? Symmetrical difference. That's happiness. That's something not in the class. Are you getting it? But from that thing that you are learning, you still learn another thing. Are you getting this? It's as if when I write 1 + 2 and I ask you what is the name of this sign, what will you tell me? It is plus. That is the idea this guy used. And this other that I said delta, probably she learned it in further mathematics. That is it. Or physics. Thank you. And even if you know how to say delta or this or symmetrical difference, you can call it changing. Under calculus, differentiation, change the velocity over time. So are you getting it? Both of them are correct. But now, in this set now, what's the correct answer? But the question I asked that what is the name of the symbol? Delta. So those that are larger. So I think I've clarified my judgment, Ali. Okay. 452. Let's continue. The symmetrical difference of set A and B written as that is the set of elements. Mr. Elijah, you have to hold over there. That's Elijah. You have stand up, come and meet me. You want the question now? The symmetrical difference of set of set A and B written as that is the set of elements that belong to A or B, but not both. That belongs to A or B, but not both. Do you get it? That is, some elements, it might be in A. If not in A, you find it in B. But what? Not both. Now, mathematically, you can express it as this. So, this is the last phase of this tutorial.
Yay!
So, A, symmetric difference B, you can express it as this. You find A minus B. That is the difference between A and B. Then union B minus A. That's the first formula. Second one, you can express it like this. A difference B also equals what? A stroke B. Avina, it means the same thing. Do you remember that?
Yes.
Then union what? B stroke what? B stroke A. Now that is, you first find the difference between A and B. Then the difference between B and A. Then find the union of the two. You have your what?
Delta.
Symmetry difference. You get it? Find the difference between A and B. Find the difference between B and A. The answer you get in A and B. The answer you get in B and A. Then you add them together. Like you bring them together. You make them in an union format. Now, the tip is this. Now, this is the int. Let's have it, the int. Take what is unique to each set. You take what is unique to each set. Unique, what is unique to each set. And remove the overlapping, that is intersection. You will take what is unique to each set and remove the overlapping. Then open your brackets, intersection, overlapping. Then open brackets, intersection. Now, example 1. Okay, take what is unique to each set and remove the overlapping. Open brackets, intersection. Example, this used to be our final example, then we'll call it a good tutorial. Now, example 1, given set A equals 1, 2, 3, 4. That's your set A. And your set B equals 3, 4, and 5. So, you have to find A symmetric difference B. A symmetric difference B. Now let's do this together. Now, what's the formula to find A difference of B? Formula to find A difference of B. Anybody in the house? A minus B, you know what?
B minus A.
B minus A, that's correct. And A is what? What are the elements in A? 1, 2, 3, and 4. Elements in B? 3, 4, and 5. Okay. And now the rule is that we do what? You first find A minus what? B. Yeah, do that and tell me the answer. Okay. From this side, A minus B. From this side, A minus B. 1, 2. That's correct answer. So 1, 2, Abi? Yes. Junior, now B minus A. 5.
Are you done?
5. Then, so that means A symmetric difference B is what? 1, 2, 5. Do you know the difference between, when you say difference of sets and what? Symmetric difference. For difference of sets, you just subtract. Zoom. You are done.
Zoom.
But symmetrical difference, in that case, what you do is what?
Boom.
You find the difference between the two. But you take it vice versa, Abi. A minus B, then what? B minus A, and you find the what? The union. You have a question. What do you say? Yeah. Okay. Aha. That's Janas together for I don't know what that's very nice. All this type of people now. All this type of people, then you imagine it has to be because of those things I've said and what Mr. Legacy has also said. In the examination, your mathematics, it is on rare occasion you have German setting. Do you understand what I mean by German setting? When you say German, that is fill in the gap. Aha, no option. That one is very rare, mathematics.
But GNS 101.
But there's a course called GNS 101.
GNS 106. Oh my
GNS 106. Now I don't know them, it's those that know them. You said all those ones, like German. Now, your question is this. In your option, you might be given Jetta, Abi, symmetrical what? Symmetrical difference. If it is that question is inside MTS 101, what will be your answer? Symmetrical difference. Do you get it? But if it's like in physics, what will be your answer? Yeah. Or what? Change in so. Are you getting it? Okay. And I'm pretty sure if you look at your wristwatch now, 5:04, 5:03, 5:05. 5 o'clock. Yes. So I think we are going to kind of round it up. Or we should not round it up. Okay. But what do you say? But before that, in case like maybe you want to disturb my head a bit, or you have some kind of question for yourself, let me just give you my WhatsApp contact in case. Like call it.
Don't write it up.
Okay, let me start. Let me write it. 09.
Wait.
Just write it.
It's too high.
090 So, I think this is done now together for Mr. Legacy. before you go, we also have our co-hosts. I'm pretty sure most of you might have heard of Elijah, Abi, or Easter. You'll have seen his sister. Welcome back to FUTA, Resumption, Abi. You welcome you so that you come and feel the struggle with FUTA. And aside from that, legacy this thing, websites, like you guys are lucky. When I was in another level, there's nothing like legacy. You read, you read it, but this guy, I think he loves all of you very well. Like, it's not even for only MTS, all the courses, not only 100 level, from 100 level to 500 level, all your departments, and we have like 10 faculties in the world of FUTA. Everything is there.
69 departments.
You need to give him a good appreciation. Jam your hands together for him very well.